Neanderthals, though often regarded as a primitive cousin to modern humans, were a species deeply entwined with our own evolutionary history. They are technically our sister species, having branched off from a common ancestor hundreds of thousands of years ago. Neanderthals and Homo sapiens lived side by side for tens of thousands of years, sharing the same landscapes, ecosystems, and possibly even culture. Fossil evidence suggests that Neanderthals were widespread across Europe and parts of Asia, inhabiting areas that were, for much of their existence, colder and harsher than the African environments that shaped early Homo sapiens. While Neanderthals are often portrayed as slow, brutish cave dwellers, recent discoveries have transformed our understanding of them. They weren't just surviving in the challenging climates of Ice Age Europe, they were thriving, with evidence showing advanced tool use, symbolic thinking, and even possible burial rituals. This indicates that Neanderthals were far more intelligent and culturally sophisticated than they have been given credit for. Genetic studies reveal that modern non-African humans carry between 1 to 2% Neanderthal DNA, proving that interbreeding between Neanderthals and early modern humans occurred. This genetic inheritance has influenced everything from our immune systems to physical traits like hair and skin. Though the Neanderthals eventually went extinct around 40,000 years ago, their legacy remains both in our genes and in the archaeological record, leaving us with a deeper understanding of their intelligence, adaptability, and human-like nature. One of the most striking differences between Neanderthals and modern humans lies in their physical build. Neanderthals were short by today's standards, with males averaging around 5 inches and females about 5'1". But despite their relatively modest height, their body mass was anything but average. Neanderthals had a thick, muscular build that gave them an incredibly high body mass index, BMI. Where modern humans tend to have more slender frames, Neanderthals were built like powerlifters or strongmen, with a muscular mass far exceeding the average person today. Their large, heavy frames made them well adapted to the cold, harsh environments they often inhabited. A higher BMI, particularly in the form of muscle and fat, helped them retain heat and survive frigid temperatures during Ice Age Europe. The bulkiness also provided strength and durability, crucial for hunting large game and enduring physical challenges. It's not just that they were stocky, their bones and muscles were built to withstand incredible strain. Imagine a species that, on average, would weigh significantly more than a modern human of the same height, with muscle mass distributed throughout their limbs and torsos in a way that provided them with remarkable power and endurance. While the typical Neanderthal might not tower over a modern human, they more than made up for it with sheer bulk and strength. Their heavy musculature, combined with their shorter, wider frame, would have given them a squat, powerful appearance. They were perfectly suited to their environments, where raw physical power was a necessity for survival, whether it was fending off predators, hunting massive game, or simply enduring the cold. The skeleton of a Neanderthal offers some of the most compelling evidence of their extraordinary strength and physical robustness. Compared to modern humans, Neanderthals had much thicker bones, a characteristic that gave them an incredibly solid foundation. While human bones are light and somewhat fragile in comparison, Neanderthal bones were built like reinforced steel beams, capable of withstanding massive forces without breaking. This was necessary for the kind of lifestyle they lived, which required not just hunting large animals, but also grappling with their prey in up-close, dangerous encounters. One of the most notable features of the Neanderthal skeleton is the massive rib cage, which was barrel-shaped rather than the more conical shape seen in modern humans. This rib cage provided the framework for a powerful core, essential for both physical labor and survival in their cold, demanding environments. Their broad shoulders, thick arms, and wide pelvis all contributed to a body capable of immense physical strength. The thicker bones also suggest that Neanderthals lived hard, physical lives, and their skeletons were under constant stress from the heavy loads they carried and the high-energy activities they engaged in daily. Even their fingers and hands were more robust than ours. Neanderthal hands were not only larger, but also more muscular and capable of gripping with incredible force. This would have been a great advantage in tool use and crafting, as well as in hunting and other tasks that required significant manual dexterity combined with raw strength. Their thick skeletal structure and powerful grip show that they were built for a life of intense physicality from the moment they were born until their final days. When it came to food, Neanderthals weren't just hunting small game. They were taking down massive animals that roamed the Ice Age landscape. This required a combination of strategy, strength, and bravery, as the animals they hunted were often far larger and more dangerous than anything we commonly encounter today. Neanderthals regularly hunted woolly mammoths, large deer, bison, and even rhinoceroses in certain regions. These animals would have been difficult and dangerous to hunt, but the rewards were immense. A single large kill could provide a Neanderthal community with food for days or even weeks. To succeed in hunting these enormous animals, Neanderthals relied on close-quarters tactics, using thrusting spears and other tools designed for short-range attacks. Unlike modern humans, who often relied on throwing weapons and distance, Neanderthals got up close with their prey. This means they had to physically overpower their targets, something that required enormous strength, endurance, and a high tolerance for danger. The risks were immense, as a misstep could result in injury or death, but their physical robustness allowed them to survive such high-risk hunting techniques. There is also evidence that Neanderthals cooperated in their hunts, working in groups to corner or ambush large prey. This not only speaks to their physical strength, but also to their intelligence and ability to strategize. After taking down an animal, Neanderthals likely worked together to butcher the carcass, preserving the meat, using the bones for tools, and even potentially using the hide for clothing or shelter. This method of hunting and resource utilization made Neanderthals efficient predators in a harsh and unforgiving world. Neanderthals possessed strength that went beyond what most modern humans can even imagine. Their incredible physical power was a result of both their muscular build and their day-to-day activities, which demanded constant, intense physical exertion. Living in the wild, Neanderthals faced challenges that would have tested their strength daily, whether they were hunting large, dangerous prey, constructing shelters, or moving heavy objects. It's been estimated that the average Neanderthal was about 25 to 30% stronger than even the most athletic modern humans. This strength wasn't just about raw muscle mass, it was also about how they used their bodies. Their short, stocky frames gave them an enormous advantage when it came to lifting and carrying heavy objects. With shorter limbs and a more compact torso, Neanderthals were built to withstand great physical stress. Their bones, far thicker than ours, could handle heavier loads without fracturing, and their joints were larger and more resilient. This means that Neanderthals could likely carry far more weight than modern humans, potentially lifting or hauling hundreds of pounds with relative ease. Additionally, their daily activities would have further conditioned their muscles. Neanderthals didn't have the luxury of modern technology or domesticated animals to help with heavy lifting or transportation. Every task, from hunting to gathering materials for tools and shelter, had to be done manually. This constant exertion created bodies that were not only strong, but also incredibly durable. Even their tools reflect this. Neanderthals primarily used thrusting spears and other close combat weapons, meaning they were engaging in physically demanding hunts that required immense strength to overpower their prey. What's more, their strength wasn't limited to their upper bodies. Their legs too were thick and powerful, allowing them to traverse rugged terrain with ease. Whether they were climbing rocky hillsides, crossing rivers, or chasing down large game, their legs provided the stamina and force needed to move quickly and powerfully across their environment. It's no wonder that Neanderthals were often able to take down massive animals that weighed many times their own body weight. Strength was simply part of their daily survival. Neanderthals weren't just strong, they were remarkably tough. Fossil evidence shows that many Neanderthals suffered severe injuries during their lifetimes, yet they often recovered from these traumas in ways that seem almost superhuman. The types of injuries found on Neanderthal skeletons would have been debilitating, even fatal, to modern humans without modern medical care, yet many Neanderthals lived for years after suffering them. For example, scientists have found Neanderthal bones showing signs of multiple healed fractures, injuries that were likely sustained during hunts or skirmishes with dangerous animals. In one famous case, the skeleton of an older Neanderthal male nicknamed Shanidar 1-inch was found with numerous injuries, including a crushed eye socket, a damaged arm that had been amputated or severely impaired, and a significant leg injury. Despite all this, Shanidar 1 survived into old age, showing that Neanderthals were capable of enduring and recovering from traumatic injuries that would incapacitate or kill most modern humans. It wasn't just their bones that were resilient. Neanderthals also had the capacity to recover from severe cuts, gashes, and perhaps even internal injuries. This durability suggests that their bodies were not only physically stronger than ours, but also had a higher pain tolerance and faster recovery rates. Some researchers believe that their thick, muscular bodies may have provided a form of natural armor, shielding vital organs from damage and allowing them to heal more quickly. Even in a world filled with predators and constant physical danger, Neanderthals seemed to bounce back from injuries that would lay low most other creatures. In addition to their physical resilience, there's evidence that Neanderthal communities took care of their injured, helping them survive and recover. This suggests a degree of social cooperation and empathy, where the injured were cared for by others until they were able to function independently again. Without such care, it would be difficult to imagine how Neanderthals could survive such traumatic injuries for as long as they did. One of the most incredible aspects of Neanderthal physiology was their ability to survive the extreme cold, and 74% of them lived in environments that were subject to harsh, frigid climates. The last ice age was an unforgiving period, with glaciers advancing and retreating, drastically altering the landscape and making survival incredibly difficult. Yet Neanderthals thrived in these conditions for tens of thousands of years. Their thick, muscular bodies played a key role in keeping them warm. Fat, especially around their torso, likely helped insulate them against the cold, and their large lung capacity, which we'll discuss more shortly, allowed them to take in more oxygen, which could help keep their bodies running at full capacity even in low temperatures. Moreover, their shorter, stockier build was another advantage. Smaller bodies lose less heat, and Neanderthals were built in such a way that they could retain warmth more effectively than their taller, slimmer Homo sapiens counterparts. But beyond their physical adaptations, Neanderthals were also highly resourceful in finding ways to stay warm. Evidence suggests they made use of animal hides and furs, perhaps even fashioning crude clothing or blankets to protect themselves from the elements. They also likely built shelters, either from natural caves or from materials like wood and animal skins, to provide themselves with protection from the wind and snow. There's even evidence that Neanderthals used fire not just for cooking, but as a critical tool for warmth and survival. Their ability to control and maintain fire would have allowed them to survive in regions where temperatures dropped to deadly levels. The fact that such a high percentage of Neanderthals were able to endure these extreme conditions speaks to their remarkable toughness and adaptability. One of the more surprising traits of Neanderthals was their massive lung capacity. Neanderthals had much larger rib cages than modern humans, which housed large lungs capable of taking in far more air. This allowed them to survive in environments with lower oxygen levels, such as high altitudes or colder climates, where the air would have been thinner and harder to breathe. Neanderthals likely needed this large lung capacity to support their incredibly active, physically demanding lives. Hunting large game, traveling long distances, and enduring cold temperatures all required a high level of stamina and the ability to keep their muscles oxygenated. Their larger lungs meant that with each breath, they were able to take in far more air than modern humans, giving their muscles the oxygen needed for intense bursts of physical activity. This would have been a crucial advantage in hunting, where they may have had to run or exert themselves for long periods without tiring. But it wasn't just about stamina. Neanderthals also lived in an era where the atmosphere may have contained different concentrations of gases than it does today, and the ability to process more air would have been an important survival trait. Their large lungs also helped them stay warm by enabling them to generate more body heat through increased respiration. The combination of these factors made Neanderthals incredibly efficient at using oxygen to fuel their large bodies, giving them an advantage in both survival and physical performance. Their capacity to gobble air also has implications for their metabolism. Neanderthals needed an enormous amount of energy to fuel their massive muscles and keep their bodies warm in cold climates. A large lung capacity would have allowed them to metabolize food more effectively, converting calories into energy that could be used to power their daily activities. In this sense, their lungs were not just about survival. They were a key component of their superhuman physicality. Neanderthals had incredibly high caloric needs, far greater than modern humans, due to the demanding nature of their environment and lifestyle. To maintain their massive muscular bodies and survive the cold climates of Ice Age Europe, they needed to consume a significant amount of energy daily. Estimates suggest that a typical Neanderthal required anywhere from 3,500 to 5,000 calories a day, depending on factors like age, sex, and level of activity. This is significantly more than the average modern human, who generally needs about 2,000 to 2,500 calories per day. These high caloric demands were met primarily through a diet rich in animal protein and fat. Neanderthals were expert hunters who relied heavily on large game such as woolly mammoths, bison, deer, and other megafauna. The fat and meat from these animals provided the dense energy needed to fuel their physically strenuous lifestyles. Fat, in particular, was a crucial part of their diet, as it is a more concentrated source of calories than carbohydrates or protein, and would have been essential in providing the energy needed to keep their bodies running, especially in cold conditions. However, the environment Neanderthals lived in wasn't always abundant with food. Seasonal changes and the harsh Ice Age climate meant that food availability fluctuated. Neanderthals needed to be opportunistic, eating as much as possible when food was available and perhaps going through periods of scarcity during lean times. This likely led to their bodies being well adapted to surviving on high-protein diets for long periods, and their ability to process animal fat and protein efficiently was probably crucial for their survival. Their hunting success, however, wasn't always guaranteed. When large game wasn't available, Neanderthals had to resort to other food sources like plants, berries, and smaller animals, though their diet was still predominantly meat-based. They likely foraged for whatever they could find in their environment to supplement their caloric intake. Additionally, evidence suggests they might have used fire to cook food, which would have made it easier to digest and provided more available nutrients. In short, their huge caloric needs were a direct reflection of the physically demanding lifestyle they led, their extreme muscle mass, and the cold environments they lived in. Every calorie counted for Neanderthals, and they adapted to get the most out of the food sources available to them. While Neanderthals are often depicted as slow and lumbering, this is a misconception. Despite their heavy muscular builds, Neanderthals were actually quite fast and agile, especially when it came to short bursts of speed. Their thick bones and powerful leg muscles allowed them to move quickly over rough terrain, which was essential for hunting large animals or escaping predators. Their bodies were built more for power than endurance, but in the moment, Neanderthals could summon an impressive amount of speed. Their short, stocky legs, though not built for long-distance running, were ideal for sprints and sudden bursts of power. This would have been particularly useful in ambush-style hunting, where Neanderthals would need to close the distance between themselves and their prey quickly. For instance, when hunting large game like mammoths or bison, speed and agility were necessary to position themselves for a fatal strike. Their physical build, including large calf and thigh muscles, provided the kind of explosive power needed to move fast in critical moments. However, this need for speed didn't mean Neanderthals were marathon runners. They were built for short, intense efforts rather than sustained, long-distance running like modern humans. Early Homo sapiens, with their longer limbs and lighter frames, were better suited for endurance hunting, which involved tracking prey over long distances until it was exhausted. In contrast, Neanderthals likely used their speed in short bursts during hunts, relying on ambush tactics or teamwork to corner or surprise their prey. Their speed and agility also would have been critical in their everyday lives, from navigating rocky or icy terrain to escaping from predators like large carnivores. Living in such a physically demanding environment required Neanderthals to be both strong and quick on their feet. Their ability to move rapidly, despite their bulk, was another key adaptation that helped them survive for as long as they did. Another fascinating aspect of Neanderthal biology is their muscle fiber composition, which likely contributed to their incredible strength and speed. Modern humans have two main types of muscle fibers: slow twitch and fast twitch. Slow twitch fibers are used for endurance and sustained activities like long-distance running, while fast twitch fibers are responsible for explosive power and short bursts of strength. Based on their physiology and lifestyle, it's believed that Neanderthals had a higher proportion of fast twitch muscle fibers. Fast twitch fibers are what allow for quick, powerful movements, such as sprinting, jumping, or lifting heavy objects. These fibers fatigue more quickly than slow twitch fibers, but they produce a lot more force in a short amount of time. Neanderthals' heavy muscular build suggests that they were optimized for these types of powerful movements rather than for endurance. This would have been perfect for their hunting strategies, where quick bursts of strength and speed were necessary to take down large animals or defend against predators. This muscle composition would also explain why Neanderthals were able to perform so many physically demanding tasks that required short, intense periods of exertion. Whether it was carrying heavy loads, climbing, or engaging in hand-to-hand combat with animals, Neanderthals' fast twitch fibers gave them the strength and speed to accomplish these feats. Over time, their bodies likely adapted to prioritize these fibers because they were more suited to the high-intensity, survival-based tasks that dominated their daily lives. Furthermore, having more fast twitch fibers would have complemented their environment. In the colder climates where Neanderthals lived, conserving energy was essential, and bursts of activity followed by rest were more efficient for survival than prolonged exertion. This allowed them to engage in short, powerful efforts when needed and conserve energy during downtime. Although Neanderthals had slightly larger brains than modern humans, this doesn't necessarily mean they were smarter in the way we define intelligence today. The difference in brain size is only part of the picture. It's how the brain was used that truly sets Neanderthals apart from Homo sapiens. While both species had highly developed brains, Neanderthals had larger occipital lobes, which are the parts of the brain responsible for processing visual information. This suggests that Neanderthals had a stronger reliance on their sense of sight, which would have been crucial in the environments they lived in. Larger occipital lobes would have given Neanderthals superior visual acuity, meaning they could likely see farther or more clearly than modern humans. This would have been a key advantage when scanning for prey, spotting dangers in the landscape, or navigating through the dense forests and open plains where they hunted. Excellent vision would have been vital for survival, especially in low-light conditions such as dusk, dawn, or dense fog, which were common in the environments they inhabited. However, while they had larger visual processing areas, Neanderthals had smaller frontal lobes, which are responsible for higher-level thinking, problem-solving, and social interactions. This could suggest that Neanderthals, while highly capable of surviving in harsh environments, may not have been as skilled in abstract thinking or complex social organization as Homo sapiens. The difference in brain structure could explain why Homo sapiens eventually outcompeted Neanderthals, particularly in terms of long-term planning, innovation, and forming larger, more cohesive social groups. But this doesn't mean Neanderthals weren't intelligent in their own right. Their brains were clearly adapted to the challenges of their world, and their larger visual centers indicate they were highly specialized in skills that Homo sapiens may have lacked. Their brain size also suggests they were capable of tool use, complex hunting strategies, and even possibly forms of symbolic behavior, as indicated by discoveries of possible art and burial sites. One of the most distinctive features of Neanderthals was their incredibly strong and robust jaws, which were significantly more developed than those of modern humans. This powerful jaw structure was accompanied by large, thick teeth, both of which played an essential role in their survival. Their chunky jaws were not just for show. They were a crucial adaptation for their diet and lifestyle. Neanderthals primarily consumed a diet rich in meat, and chewing the tough, sinewy flesh of large game animals would have required significant bite force. Their larger jaws and teeth provided the necessary strength to process this type of food. Unlike modern humans who have evolved smaller jaws due to the introduction of softer, cooked foods, Neanderthals still relied on their ability to tear through raw or minimally cooked meat. Their molars were particularly well suited for grinding down tough plant matter and fibrous foods, suggesting they had a more versatile diet than previously thought. Their jaw structure also indicates they may have had a greater need for strength in the face and neck muscles to support the heavy chewing load. This could explain why Neanderthals had more pronounced brow ridges and broader, flatter faces compared to Homo sapiens. Their face and jaw were shaped to handle the rigors of a diet that required intense chewing and processing of hard-to-digest food sources. This adaptation, while highly functional, also contributed to their unique appearance, setting them apart from our more gracile features. The large, durable teeth of Neanderthals have also shown significant wear in many fossils, suggesting that their teeth were used for more than just eating. Some researchers believe that Neanderthals used their teeth as tools, holding objects in their mouths while working with their hands. This kind of wear pattern on the teeth is indicative of repetitive gripping, where the teeth acted almost like a third hand. For example, they might have held leather or other materials between their teeth while cutting or shaping it with tools. This third-hand usage highlights how Neanderthals adapted their bodies to the tasks required for survival. In environments where every resource had to be maximized, their teeth became multi-purpose tools. This would have been incredibly useful in tasks such as preparing animal hides for clothing or shelters, where holding an object steady with their teeth allowed their hands to work more efficiently. It also underscores their ingenuity in adapting their physical bodies to suit the tasks of their daily lives. While using their teeth in this way likely saved time and effort, it came with a cost. Fossil evidence shows that many Neanderthals suffered from significant dental wear and even damage to their teeth, likely due to the hard, repetitive use. However, this wear didn't seem to significantly impact their ability to survive, another testament to their toughness and resilience. In recent years, advances in genetics have revealed that most modern humans, particularly those of non-African descent, carry a small percentage of Neanderthal DNA. This discovery has shed light on how interbreeding between Neanderthals and early Homo sapiens not only occurred, but also left a lasting impact on the genetic makeup of today's populations. While the percentage of Neanderthal DNA in modern humans is small, typically around 1 to 2%, its influence is surprisingly significant. Some of the Neanderthal genes that persist in modern humans are linked to traits that have helped our species adapt to different environments. For example, certain Neanderthal genes are associated with improved immune responses, particularly in relation to fighting off viruses and infections. These genes may have been beneficial to early Homo sapiens as they moved out of Africa and encountered new pathogens in Europe and Asia, where Neanderthals had lived for hundreds of thousands of years. By interbreeding with Neanderthals, early humans may have gained a survival advantage through these inherited immune system enhancements. Additionally, Neanderthal DNA has been linked to a variety of physical traits, such as skin and hair color, which helped Homo sapiens adapt to colder climates with less sunlight. Genes related to the production of keratin, a protein that affects skin, hair, and nails, were passed down from Neanderthals, potentially aiding modern humans in growing thicker hair or more resilient skin. This would have been especially useful in the colder environments of Ice Age Europe, where thicker hair and tougher skin could help protect against the elements. However, not all Neanderthal genes have been entirely beneficial. Some research has shown that Neanderthal DNA might also be linked to certain modern health issues, such as an increased susceptibility to autoimmune diseases, allergies, or even nicotine addiction. This suggests that while interbreeding provided early Homo sapiens with some survival advantages, it also introduced certain genetic risks that persist in populations today. Despite these mixed effects, the presence of Neanderthal DNA in modern humans highlights the complexity of our evolutionary history. Neanderthals were not just a distant, extinct relative. They contributed directly to who we are today. Their genetic legacy has helped shape our immune systems, our physical traits, and even some of our health risks, making them an integral part of the human story, one that continues to influence our biology thousands of years after their extinction. In many ways, the Neanderthal DNA we carry today is a reminder of the deep, intertwined history between our species and theirs, showing that while Neanderthals may have disappeared from the Earth, they left an indelible mark on the human lineage.